Okay, this is your Stat Sensei going over the scenario 3, which is the last problem on the most recent test that we've taken. So here we take a look at this question. So bone mineral density, or BMD, is a measure of bone strength. It is defined as the ratio of bone mass to the cross-sectional area of the bone that is scanned and is expressed in units of grams per square meter. Recent studies suggest that peak in bone mass density in women is achieved between the ages of 15 and 40, and bone mass declines after 45. Decreased bone mass density is associated with increase of bone fracture. In a recent study, the impact of regular physical exercise on women in differing stages of bone mass development was examined. A simple random sample of 62 women between the ages of 41 and 45 and with no major health problems were enrolled in the study. The women were classified into one of two following groups based on their level of exercise: sedentary, minimal participation in physical exercise, and walkers, walking at an aerobic pace at least 135 minutes per week during the past 3 years. This group contained 31. So we have two separate groups. These two separate groups tell me I'm working with some sort of two sample, all right? Excuse me for that. So some sort of two samples. And then it says, so we have it written down, and we have a mean bone mass of 1.15 for sedentary, 1.2 for walkers, with the standard deviation here and standard deviation there. Can it be determined at the 1% level? All right, so they gave me a significance level. So this tells me I'm running a hypothesis test versus being a confidence interval. And we already said we have two independent groups. So this is going to be a two sample t-test that we need to be running. So our null hypothesis, mu1 equals mu2, and mu1 is less than mu2 because we're trying to see whether or not sedentary have less than bone mass than women who walk. And I need to make sure I define it that way. Mu1 equals the true population mean bone mass density for sedentary women. Mu2, the true population mean bone density for women who walk. So basically I'm saying density for sedentary is less than density for walkers. You could have also expressed it as mu1 minus mu2 equals 0. And the alternative in that case would be mu1 minus mu2 is less than 0. All right. So conditions, I'm combining my conditions, but make sure that you talk about both. Here we have random sample, and it was given for both. We have two groups of 31. So 31 divided by 0.1310. So sample is less than 10% of the population. Both sample groups have 31 women. It's reasonable to assume that there are at least 310 women who are sedentary and at least 310 women who are walkers. So that's a reasonable assumption. Independence, reasonable to assume that the BMD of sedentary women does not impact that of the walkers and vice versa. The two groups are independent. Both sample sizes are greater than 30, so the distribution of means, all right, and please make sure that you use that phrase, distribution of means, the distribution of sample means would be even more correct, are normal by central limit theorem for both the sedentary group and the walkers. So please change that to sample means. All right. So then we have our formula, and our formula is just going to be x bar 1 minus x bar 2, standard deviation of 1 squared over sample size 1, standard deviation of sample 2 squared. And we just pull that straight off of the chart. Okay, so let's go back to that. I think there were actually some math input, calculator input errors on this problem. So stat test, and I go to number 4, which is two sample t-test. Oops, help if I go to the right place. Stat test, two sample t-test. There's my sample mean 1 and my standard deviation of 1. Then I need my sample size of the first one, standard deviation of 2, and sample mean of 2, and then my standard deviation of 2. Please be careful that you don't swap the order on these. If you do, you'll get the wrong answer. And my alternative hypothesis was a less than, so I need to make sure I have less than. We never pool when we're working with means. And so there's my information, and I'm going to write all of that down. And once again, this is a good check. And I would check these every single time. Did I input my data right? 1.15, 1.209, standard deviation, 0.068, 0.067. Make sure those match. Then we have our sample sizes. Okay, so make sure those matches so you don't get caught with a careless error. So I've plugged them in, and you have to plug it in, and you have to have the formula, make sure you have the squared and square roots, etc. And we got, when we did that, 3.38 and 0.006. And so here's what we basically said. We essentially said this. We essentially said that we were claiming that there was no difference. All right. And we ended up getting a T statistic of negative 3.828. And we found this probability. All right. Well, that probability is 0.006. That's less than alpha. And by the way, that was another thing. You never have probabilities of greater than 1. So make sure that if it looks like it's greater than 1, that you check for this. Because if you write down that you have a probability of greater than 1, you're probably getting no credit for the entire problem. Because that's you cannot have probabilities of greater than 1. So do not make that error. So our p-value is 0.006, and we reject the null. There is sufficient evidence at alpha equal 0.01 to suggest that the true population mean of bone mass density for sedentary women is less than the mean of those that are regular walkers. And once again, that's just our basic standard. You always have to go back to that. Here's where this came from. This is where this came from. This was the alpha level that they give us. The true population mean density for sedentary is less than the mean of regular walkers. Sedentary, so looking at my alternative, sedentary is less than walkers. Sedentary is less than walkers. On average, women that walk have a higher BMD than those who are sedentary. Or you could say on average, women that are sedentary have a lower BMD than those who are walkers. So basically it supports that. And it says, based on the study, can we conclude that the converting sedentary women into walkers would increase their BMD? Justify your answer. Well, when we looked at this, we had a significant response. So basically, we know that there's a relationship. Those that walk tend to have more BMD than those who are sedentary. So it seems like you could do that, but that's not what was tested. So basically, this was an observational study and not an experiment. Thus, it would be incorrect to assume causation and be incorrect to determine that changing sedentary women to walkers would increase BMD. All right. Why? Not required, but it's been possible that there are other factors such as weight, diet, or general health that may be negatively impacting the BMD of the sedentary women. It's also possible that the reason they are sedentary is because they don't feel well and they're not as healthy or something along those lines, even though they tried to control for that. But nonetheless, it was an observational study. So even though it was statistically significant, we cannot say causation. We can only say causation for experiments. All right. Thank you for watching. And I hope this helped with clarify any issues that you may have had. Thank you.